Hi guys, today we're going to learn about symmetry, asymptotes, curve sketching, and limits at infinity. Mainly we're going to learn about limits at infinity. And we're going to connect that with the calculus knowledge that we have to find horizontal asymptotes. When reviewing the rules for determining possible horizontal asymptotes of rational functions, please note that we're talking about rational functions. From calculus, you can use the concept of limits and calculus to explain why those rules are true. Okay, so what we're going to do here is you're going to see that we're going to use the fact that we know a lot about limits. Specifically, we're going to analyze when the limit of x approaches, well, the limit when x approaches to positive or negative infinity of the function f of x. And whatever this gives you, as the result, we're going to conclude whether we have an horizontal asymptote or not. So, the first option that you have back in the day, it was when the degree of the numerator is less than the degree of the denominator, aka big on bottom. Then, what we have in calculus is that the limit is 0. Back in algebra 2 on precalculus, what you have is that the horizontal asymptote was y equals 0. So here what you have, you're going to take the limit when x approaches to positive or negative infinity of the function f of x, and that should give you 0. Okay? So, now, the second case is if the limit of the numerator equals the degree of the denominator, okay, aka exponents are the same, divide coefficients, then the limit is going to be the ratio of the coefficients of the highest degree. What you have is the limit when x approaches to positive or negative infinity of the function f of x is going to be equal to the number, aka the coefficient of the numerator's highest power, divided by the coefficient of the denominator highest power. This is going to be a number, maybe it's a fraction. Either way, you know that that's going to be your horizontal asymptote, okay, and that's exactly what you have back in algebra 2, okay, and pre-calc. Now, the last case is if the degree of the numerator is greater than the degree of the denominator, big on top. You know that big on top, it was pretty much when you were concluding that the horizontal asymptote, it's none. You might have a slant asymptote in this kind of situations, not necessarily, but you might. Okay, then you have that the limit does not exist. In this situation in calculus, what you have is when you have the limit when x approaches to positive or negative infinity of f of x, that's going to lead you to a positive or negative infinity. Okay, and you're going to see this, how nice it is, because I remember that back when you were in precalculus and algebra 2, pretty much you were memorizing these rules. Now we have a way to show all our work, and it's going to be really awesome. Okay, so let's look at the following example so you can see how good is this method. Okay, so we're going to evaluate the following limits, and the hint that I'm giving you here is that you need to divide each term in the rational expression by the highest power of x that appears in the denominator. Please note something very important. I'm already telling you that you're going to look at the highest power on the denominator. Then you're going to apply the properties of limits to evaluate each piece, okay, each term, and find the limit at infinity. Please note that this only works when you're finding the limits at infinity, okay? So there's two things that you need to have to basically follow this process that we're about to do, okay? And that's what it's going to represent the end behavior of the function that you have. So we read A, and we have that the limit when x approaches to infinity of 3x minus 1 divided by 2x plus 5. So what are you going to do? The first thing that you're going to do, you can see that the degree of the numerator and denominator are the same, degree 1, degree 1. What you see is that the highest exponent of the denominator is going to be x to the power of 1. So what we're going to do here is we're going to divide each term that you see in this equation by x. Okay, so you have that it's going to be the limit when x approaches to infinity of what? 3x divided by x minus 1 divided by x, because I'm here. Okay, after that we're going to, sorry, because you know that I cannot do lines, okay, so you have that it's going to be 2x divided by x plus 5 divided by x. Okay, so you see that and you're like, what in the world is that? Well, we are going to simplify. So you have the limit when x approaches to infinity, and what's this? This is going to be cancel, so that's a 3. We cannot cancel anything in the negative 1 over x, so you leave it like that. Okay, after that, what do you have in the denominator? So in the denominator, what you have, you can cancel this 2, so you have that's only 2, plus 5 divided by x. Do you see that I cannot cancel anything? So you have the situation, which is nice. Now, analyze the situation that you have. The 3 stays as a 3. Okay, if you have negative 1 divided by technically infinity, this is going to fly to what? To 0, okay? And this is going to also fly to 0. So if you have 3 minus 0, you have that that's going to be 3, and the denominator, you have 2 plus 0, that's going to be 2, and that's it. Isn't that beautiful? Now, what would happen if instead of that we have the same equation but the limit when x approaches to negative infinity? So let's do it. So you have the same situation. again, what you can see here is that the denominator's highest power is the same, okay, x. Okay, so we're going to divide every single term by what? X. Okay, so you have this equation. Okay, and then you have 2x divided by x plus 5 divided by x, and this is going to be equal to, pretty similar to the previous problem. So what do you have here? You have 3 minus 1 over x divided by 2 plus 5 divided by x. You can see that this flies to 0, this flies to 0, and indeed, what do you have here? You have that this is 3 over 2. Therefore, what's your conclusion here? Your conclusion is that your horizontal asymptote, indeed, you only have one, and it's at y equals 3 over 2. Okay? So what we have in C, what do you have? You have that the exponent, okay, of the numerator is going to be 2, the degree of the numerator is 2, and the degree of the denominator is 1. Therefore, we're going to divide, okay, all of the terms by what? X. Okay, again, x, y, x, because that's the highest exponent of the denominator. So you have 3x squared divided by x minus 1 divided by x divided by, what's that? 2x divided by x plus 5 divided by x. So what do you have? You are going to reduce, okay? When you reduce this, what do you have? You have that this is 3x minus 1 over x, which we cannot reduce, and then you can reduce this one. This is a 2 plus 5 over x. So what happens here? What you see is that this flies to 0, this flies to 0, but what's this? That doesn't fly to 0. When you plug the infinity, what's 3 times infinity divided by 2? This is positive infinity. So you have that this is positive infinity. Similarly, what you're going to have here, as you can see, this the only difference between this one and this one is the negative infinity. So let's do it. The limit when x approaches to negative infinity of what? 3x squared, what are you going to divide it by? The highest exponent of the denominator is x, so we're going to divide everything by x again. Okay, so you see here the pattern. So we have this, okay? Again, we're going to simplify the situation, okay? And this is negative, and I don't know why I put that was negative, but that should be positive, okay? So this is negative, okay? So this is going to be 3x minus 1 over x divided by 2 plus 5 over x. So what happens here? This flies to 0, this also flies to 0. What you recognize here is that 3 times negative infinity divided by 2 is going to be negative infinity, okay? Because this is negative, okay? So that's the difference that you have here. This is talking about the end behavior. Back in Algebra 2 and pre-calculus, what you have is that you have no horizontal asymptote, which is completely true. Okay, why? Because these are not real numbers. Okay, they are infinite. Okay, so that's what you have. Okay, so the last one that we have here on this page, what's the business on this one? You can see that the exponent of the highest exponent on the denominator is going to be x squared. Okay, so you can see that both of them are the same expression, so let's see if we get the same. Okay, so what happens here? We're going to divide everything by x squared. Why? Because it's the highest degree of the denominator. So you have 3x divided by x squared minus 1 divided by x squared. All of this divided by 2x squared divided by x squared plus 5 divided by x squared. So you need to cancel out stuff and things here. Okay, so you have the limit when x approaches to infinity of what? Cancel this. Okay, so you have 3 divided by x minus 1 divided by x squared, because we cannot cancel anything on this ratio. Then here we can cancel out everything, so you have only the 2 plus 5 divided by x squared, which we cannot cancel anything there. Again, you can see that this flies to 0, this flies to 0, and this flies to 0. So it's very beautiful. Why? Because you have 0 over 2, and this is going to be equal to 0. Okay? So you can see that. Hope that you understand that situation. As you can see here, what are we going to do? Let me put it over here so we have a little bit more space. Okay, so you have the limit when x approaches to negative infinity of the same situation. So again, your highest degree of the denominator is going to be x squared. So you have that it's 3x divided by x squared minus 1 divided by x squared, everything divided by 2x squared divided by x squared plus 5 divided by x squared. Okay, so we are going to again simplify the situation. Okay, so you have this. Okay, so you have that it's 3 over x, because this one cancels with this one, and then we have negative 1 divided by x squared divided by 2, okay, because they are the same exponent there, and then plus 5 divided by x squared. Again, you can see that everything flies to 0 except the 2 that we have in the denominator, so you have exactly the same, 0 over 2, which is equal to 0. So this is telling you that this equation has an horizontal asymptote at y equals 0, which is consistent with what we learned back in Algebra 2 and Pre-Calculus. So for this problem, what you have is something similar. So what we have here is you have that the highest coefficient of the denominator is going to be the square root of x squared. But what you need to also take in account is that the x is approaching to infinity. Therefore, what you have is that x is greater than 0. Therefore, what you have is that x squared square root of that is going to be equal to x. Okay, with this being said, okay, because you know that the square root of x squared is going to be plus minus x, but in this situation you know that that's not going to fly with limits, okay, because you can see that the x is approaching to positive infinity. Okay, then what you're going to do here is following the same process that we learned on the previous example. So you have the limit when x approaches to positive infinity is going to be the same as 2x divided by x, because you have the situation, all of this divided by what? The square root of x squared divided by x squared plus 4 divided by x squared. Okay, so you have the situation. Now simplify this expression. You have the limit when x approaches to infinity. This x's they cancel, so you have only the 2 at the top, and then in the denominator you have the square root of 1, because this cancels, plus 4 divided by x squared. So what you can see here is that you can see that there's 4 divided by x squared. When this approaches to infinity, that flies to 0. So what we have here is you have a 2 divided by root 1, and this is going to be equal to 2. So this is telling you that the horizontal asymptote of that equation that you have over there is going to be y equals 2. If you analyze the same situation but with a negative infinity, with the x approaching to a negative infinity, the big difference is going to be that you can see that the x is going to be less than 0, because the negative infinity is on the very left side of your graph. So what you have is that the square root of x squared is going to be equal to negative x. So what we do here is you have the limit when x approaches to negative infinity, and then what you have is 2x divided by negative x. Please note that here I'm dividing by negative x because we have this statement, and this statement happens because we have the x approaching to negative infinity. Then you have that all of this is going to be divided by the square root of x squared divided by x squared plus 4 divided by x squared. So when you simplify this, you have that this is going to be the limit when x approaches to negative infinity of what? Negative 2 divided by square root of 1 plus 4 divided by x squared. So you can see that all the situation that you have over here flies to 0. So what you have here is a negative 2 divided by root 1. So what you notice here is that this is going to be equal to negative 2. So what you can conclude from this is that the horizontal asymptote of this situation, okay, of this function that you have over here is going to be negative 2. Meaning, in this situation, we're going to have 2 horizontal asymptotes. Yes, that's how it works, okay, because you have that square root in the denominator. Okay, so now, are we going to do the same approach over here? Not necessarily. Why? If you remember from previous lessons, what you're going to do and what you can do here is you can basically divide this and conquer. Okay, so what you can do here is you have the 1 over x, then times the limit, and then you have x approaching to infinity of the sine of 5x divided by x. If you remember from the process of previous lessons, you remember that here we were dividing by 5 divided by 5, so you have the 5 over here. So what you can see here is that I'm going to simplify it here, so you have 5, okay, the limit when x approaches to infinity of 1 over x times the limit when x approaches to infinity of what? Sine of 5x divided by 5x, okay? If you remember from previous lessons, you have that this is going to be 5 times, this is 0, times, what's this? This is another 0, so this is going to be 0, okay? So this one is different. Why? Because the numerator is not a polynomial, so we don't have the same situation, and I just wanted to realize, you to realize about that particularity, okay? So the next thing that we're going to cover here, and it's a refresher because you have learned this in pre-calculus, is an even function is a function f in which f of negative x is going to be equal to f of x. Even functions, they have y-axis symmetry. So this is what I want you to remember so you can sketch the graphs very beautifully. Okay? An example of a typical even function is f of x equals x squared. you know that the point 2, 4, it has an equivalent point, symmetric point on the other side of the graph at negative 2, 4. Okay. Similarly, you can refresh your memory about odd functions. We say that a function is odd f if f of negative x is equal to negative f of x. Odd functions, what I want you to remember is that they have origin symmetry. Origin symmetry, it means that if you have the point, in this case 2, 8, you're going to have also the point negative 2, negative 8 on the graph. The best example of an odd, simple odd function is going to be f of x is equal to x cubed. Okay, so now let's use this on the next page so you can see how simple is going to be curve sketching. In this question, what you need to do is you need to find the horizontal, vertical asymptote symmetry and intercepts and sketch the graph. So what you're going to do first, I would use and find the intercepts. Okay, so let's start with the y-intercept. You know from algebra 2 that the y-intercept, you're going to plug the 0 in your equation and this will give you 0. Therefore, your y-intercept in this function is 0, 0. Similarly, you have that the x-intercept is going to be 0, 0. And we'll go with that. So you do have that your intercept is going to be here. Now, the next thing that you're going to do, I would find the vertical asymptote. The vertical asymptote, you would equalize the denominator to 0, but you can see that this, it will give you a complex number, which we don't care in calculus, therefore you don't have a vertical asymptote. Okay? Now, the next one that we have is horizontal asymptote. The horizontal asymptotes, since we are now in calculus, what you're going to do is you're going to take the limit when x approaches to positive infinity of what? The equation that you have, 3x divided by square root of x squared plus 1. Okay, so what you have here is a similar example of the ones that we just solved. So you have that the x is going to be greater than 0, therefore what you have is that the square root of x squared is going to be equal to x. Therefore what we're going to do here is you're going to divide by the highest coefficient of the denominator, which you know that it's going to be square root of x squared, which is equal to x. So what you have is 3x divided by x divided by what? The square root of x squared divided by x squared plus 1 divided by x squared. So what you have here is very nice, but we need to simplify. So you have that this is going to be the limit when x approaches to infinity. Cancel this, so you have 3 divided by what? Square root of 1 plus 1 over x squared. So what you have here is that this goes to 0. So what you have is 3 divided by root 1, which is going to be equal to 3. Okay, so this is telling you that the first horizontal asymptote is at y equals 3. Okay, then you need to analyze the other side. Okay, so we have the other side, which is the limit when x approaches to negative infinity. Okay, so you have that this is going to be the same expression that you had before, right? Nothing new. But here you are going to analyze when x is less than 0. Okay, so when x is less than 0, you know that the square root of x squared is going to be equal to negative x. So this is going to be equal to the limit when x approaches to negative infinity of what? 3x divided by negative x divided by the square root of x squared divided by x plus 1 divided by x squared, everything inside the square root. So you simplify this beautiful situation. You have the limit when x approaches to negative infinity, and you have that this, you have negative 3 divided by the square root of x squared divided by x squared, which actually we shouldn't put that, because that should be what? Well, that should be a 1, so yes, okay, so 1 plus 1 over x squared. Okay, so you know that this one flies to 0, right? And then you have that this is going to be equal to negative root 3 divided by negative 3 divided by root 1, which is equal to negative 3. Okay, so your other horizontal asymptote is at y equals negative 3. So let's graph what we have. We have the horizontal asymptotes, okay, so let's draw them. I'm going to draw my horizontal asymptote. One is here and the other one is here. Okay, so this is going to be your y equals negative 3. This is going to be your y equals 3. So let's draw them. Y equals 3, y equals negative 3. Okay, so this is what we have so far. Okay, now the next thing that we have vertical asymptotes and horizontal. We already found intercepts, but we need the symmetry. What are you going to do for the symmetry? For the symmetry, you are going to plug the negative x. So you have 3 times negative x, all of this divided by the square root of what was it? Negative x squared plus 1. When we clean it up, what do you have? You have that this is negative 3x divided by, you know that this, it doesn't affect the sign, so that's going to be exactly the same, x squared plus 1. So you can recognize that this is going to be equal to negative f of x, meaning your function is odd. Okay? So what do you know? This is having origin, okay, symmetry, or symmetric with respect to the origin. Okay? So what you have is that your beautiful graph here is going to look like this. Okay? From the asymptotes that we have. Do you see it? So that's what we have. That's your graph f, and that's pretty much it for today. So this is your graph, and remember, it's origin symmetry. Okay? So I hope that you find this video helpful. Bye!